Okay, so 16 of you voted for what we're going to be doing. We have a class of 75 and only 16 decided to say what they wanted for revision. But anyway, let's go with what they voted for. Here's the responses. Okay, so the highest response here was for partial fractions. I think there were 7. So 7 of you voted for that. So we'll start off with partial fractions. Then the next highest was hyperbolic trig substitution. So we'll do a few examples of that. Then the next one was integration by parts. Okay, so those were the major ones. So we'll go through those. Then the other ones were trig integrals and the integration identity proofs. If we don't finish that today, we'll do that tomorrow. Okay, but we'll go with partial fractions for today since that was the highest voted topic. Okay, like I said earlier with these, there's always more than one way of answering them. So for some of them, I'll show you the different ways of answering. So in some cases, you can do partial fractions. In other cases, you can do partial fractions or hyperbolic trig substitution. We'll go through all of the different ways. Okay, so number 1, partial fractions. Okay, if you're stuck at any point as we're going through the working, just shout out, we'll go over it again. Okay, so again, all of this stuff is for you. So if you're lost at any point, please just stop me. We have the full time to cover whatever you want. Okay, otherwise we'll go through what I've planned. Okay, so we've got the integral of x plus 2 over 3x squared plus 1. Okay, so there's a number of ways of doing this, but we're going to do it the partial fractions way. I'll just give you hints of the other ways, and then you can try it out. So here we could split it up into 2 parts. So we can have x over 3x squared plus 1 as one term. We can do a u substitution. Plus 2 over 3x squared plus 1, and that will be arctan. So you could split this up into 2 parts and have the integral x over 3x squared plus 1 and do a u sub for this, plus the integral 2 over 3x squared plus 1. And we know this will be something with arctan. Okay, so you could do it like that. But immediately we see polynomial divided by a polynomial, we can do partial fractions. Okay, so all partial fractions, right? Because if you immediately see polynomial over polynomial, you should be thinking partial fractions. But if you split it up like we did there, then there's no partial fraction stuff we have to do. We just have to do each part separately. Okay, so this will be homework. Okay, so let's go through the 2 parts. So we're going to do a u substitution for the first bit. So u equals 3x squared plus 1. du will then be 6x dx. At the top, we just have x. We don't have 6x. So we take the 1 over 6 here. X dx. Okay. So that takes care of the top part. So this is going to be the integral of 1 over 6 du over u, because u was that whole bottom part there. So this is going to be 1 over 6 natural log of u. Okay, but we don't want it in terms of u, we want it in terms of x, so we can put the 3x squared plus 1 back. Okay, so that takes care of the first bit. Now the second bit, we know it's going to be something with arctan, but the way it's written is not nice because we have 3x squared plus 1. What we want for arctan is x squared plus a squared. Then it will be 1 over a, arctan, x over a. In this form, we can't write that yet. So we have to do a little bit of work. So first, let's take the 2 out. We don't need that. So 1 over 3x squared plus 1. Okay. Again, we don't want this 3, so let's take that out. So it will be 2 over 3 integral 1 over x squared plus a third. Right, taking that out. But again, it must be x squared plus a squared. Over there, we have a third. That's not what we want. We want something squared. So that's going to be 2 over 3 integral 1 over x squared plus 1 over root 3 squared. Now we have x squared plus a squared. We can write down our answer. So this is going to be 2 over 3 times 1 over a. So 1 over root 3. So root 3. Then it will be arctan x over a. So x divided by 1 over root 3. So that will be root 3x. Okay, so we split it up into 2 problems. Instead of having one partial fractions looking problem, we split it up into a u substitution problem and the arctan problem. And then we can just put it all together. So we have the integral of x plus 2 over 3x squared plus 1 dx is equal to the first bit we had, the 1 over 6 natural log. So 1 over 6 natural log 3x squared plus 1 plus, and then the second part of the problem, the one with the arctan. So it will be 2 root 3 over 3 arctan root 3x plus c. Okay, so just put it all together. Okay, so again, if it looks like a partial fractions problem, don't jump ahead and immediately do partial fractions. See what happens if you split it up. So in this case, it looks like a partial fractions problem, polynomial over polynomial. But if you look carefully, you can split it up into 2 smaller problems and then just put it together. Okay. Also, this bottom part here, you can't really factor that nicely, so you're going to have issues with that. Okay, number 2. We have the integral of 6 plus 3x minus x squared all over x cubed plus 2x squared. Okay. Again, looks just like a partial fractions problem. We've got some polynomial divided by some polynomial. Now, we can't really split this up nicely to do anything with it, unless you see something. So we're going to just treat it like a normal partial fractions problem where we do the long division, factor the denominator, and then decompose. So first thing, do we need to do long division? The top is squared, the bottom is cubed, so no, we don't have to do any division. Next, can we factor the denominator? Yes, we can. There's a x squared there, and this x cubed, we can take out an x squared as well. So let's do that. So this will be the integral 6 plus 3x minus x squared all over. Like we said, there's x squared common factor. So it will be x squared, and we're left with an x plus 2. Okay, so factoring done. Now we do the decomposition step, step 3. So we're going to take our 6 plus 3x minus x squared divided by x squared x plus 2, and we're going to split it up. We've got x squared, that's repeated twice, so we need a over x plus b over x squared. And then the second term is just linear, so that's going to be c over x plus 2. Okay, so we just split it up. Yes?
When it's x squared, the numbers will not be linear.
Sorry?
X squared, we need to divide by x squared. The right hand side of the equation.
Yeah.
Be not linear.
No, because this is like x squared. It's like if you have x plus 0 squared, x plus 2. Think of it like that. So here we've got a linear squared, so we write it linearly twice, so just a constant at the top. And then the other one is also linear x plus 2, so it's a constant. If this was x squared plus 1, now that is irreducible quadratic. Then this would have ax plus b over x squared plus 1. Okay, So you only do the linear top part, the ax plus b, if it's an irreducible quadratic. This is not. This you must think of as x plus 0 squared. Okay, but good question. Let's get rid of all of this. Okay, so we've got our a, b, and c. All of them are linear, but the x squared is linear repeated twice. Now we need to solve for this. So let's clear the denominators. So we're going to have 6 plus 3x minus x squared is equal to, here we're multiplying by all of this denominator here. So that's going to be x plus 2 plus b x plus 2 plus c x squared. Okay, so that's just clearing the denominators there. Now you can go two different ways. You can expand out that right-hand side and then compare coefficients. So the constant here is 6, the constant there must be 6. The coefficient of x here is 3, so on the other side, the coefficient of x must also be 3. On this side, the coefficient of x squared is minus 1. On that side, the coefficient of x squared must also be minus 1. And you'll end up with 3 equations, 3 unknowns you can solve. Yeah, question? No, okay. So you would end up with 3 equations, 3 unknowns. You can solve it, right? Your MATH162 stuff. Or you could choose values of x, substitute it in both sides, and then just solve them one by one. For example, if we let x be 0, the a term goes away, the c term goes away, and we're left with b. We've isolated b, we can solve for that. So let x be 0. Okay, so then we end up with 6 is equal to 2b, so b is equal to 3. And we can solve them one by one like this. Next, if we let x be minus 2, the a term goes away, the b term goes away, we're left with c. And we can solve for that by itself. So x equals minus 2. Okay, we'll end up with minus 4 equals 4c. Okay, so c must be minus 1. Okay, and then again, you can pick something else, clear the other terms, and solve. In this case, we can pick anything and then just solve for a. So let's say x equals 1. So we're going to have 8 equals, sorry, not 8. We'll have a equals 0. Okay, so you'll end up with a equals 0 there. Some stuff will cancel. Okay, so we know a, we know b, we know c. We have everything we need for the integral. Okay, so let's put everything together. So this will be the integral. A is 0, so we can ignore that one. We know b is 3, so that's going to be 3 over x squared. And c is minus 1, so it will be minus 1 over x plus 2. Okay, and now we just integrate. So the first one, that will be minus 3 over x. And the second one, natural log, but with the minus in front. So minus natural log x plus 2. Okay. Okay, number 3. We have the integral of x, 2x plus 1 over 4x plus 1 squared. Okay, so immediately in the bottom, we see it's linear repeated twice. So like ax plus b squared. So we've got 2 of them. In the top there, we've got 2x squared plus x. Okay, so in the top, it's squared because it's going to be 2x squared. In the bottom, it is also squared, right? Because it's 4x squared. So we need to do the long division first. Okay, so don't jump ahead and see, okay, well, the bottom's factored already. I can skip steps. No, you need to check step by step. Step 1, you check for the long division. The top is squared because it's 2x squared. The bottom is squared because we've got the 4x squared. So we need to do long division. Okay, so don't jump ahead just because it looks like it's factored already. So let's multiply it out and see what we have to do. So this is going to be 2x squared plus x. And then in the bottom, we're going to have 16x squared plus 8x plus 1. And written like this, we can immediately see quadratic over a quadratic, we have to do long division. Okay, so we do that, and we end up with the integral 1 over 8, integral 1 minus 1 over 4x plus 1 squared. Okay, so you can do the long process of long division. There's a shortcut you can do. I'll show you on the side. But if you're unfamiliar with the shortcut, you can always do it the longer way. Okay, so again, there are shortcuts, but if that bothers you, the longer way will always give you the right answer. Okay, so shortcut. So let's say we have our 2x squared plus x over 16x squared plus 8x plus 1. Okay, so for the shortcut, what we want to do is make the numerator look like the denominator. Okay, so we've got 2x squared plus x. What happens if we multiply the top by 8? Then we're going to have 16x squared plus 8x. Okay, we multiply the top by 8, and we see we get part of the denominator. So that gives you an idea of what to do. So what we're going to do here is add 1 over 8 and subtract 1 over 8. Why 1 over 8? Well, we know that we have to multiply the top by 8 to get the bottom part. Okay, so adding 1 over 8, subtracting 1 over 8, we haven't done anything. But now, look what happens if I multiply the top by 8. So we're going to have 1 over 8 in front. So times by 8, divide by 8. We're going to have 16x squared plus 8x plus 1 minus 1 over 16x squared plus 8x plus 1. And now we've got it exactly how we wanted. We've got 16x squared plus 8x plus 1. That's exactly what we have in the bottom. So this is going to be 1 over 8. So the same thing divided by the same thing, that's just a 1, minus 1 over that denominator. Well, we can just write it like we had there. That's the 4x plus 1 squared, which we've got on that line there. Okay, so this is just a shortcut to do the long division. If you don't like the shortcut, you can always do it the long way. You'll get the same thing. Yeah, but if you're writing an exam, you want to do a quick shortcut to save time, it is available. Okay, now everything's factored. We can integrate immediately. So this is going to be 1 over 8. Integrating 1, that's just going to be an x minus 1 over 8 times 1 over 4 from the u substitution, and 1 over 4x plus 1. Okay. And then becomes a plus. Okay, so this u substitution here, the u equals 4x plus 1, you should be able to do that in your head by now. Okay, if you can't do that in your head, go back to the u substitution work and work at that. Okay, so that bit from the minus 1 over 4x plus 1 squared, integrating that, you should do that in one line. Okay, if you can't do it in one line, you need to go back and do some extra work. Okay, so 1 over 8x plus 1 over 32, 1 over 4x plus 1 plus c. Okay, we end up with this. Okay, number 4. Here we have the integral x over x plus 5. Okay, looks simple. Again, it's partial fractions. We've got a linear polynomial at the top, linear polynomial at the bottom. So by definition, polynomial divided by polynomial, it's a rational function. So we can do it using the partial fraction stuff. Okay, step 1, see if we have to do long division. The top degree is 1. The bottom degree is also 1. We have to do long division. Now again, you could do it the long way, or you could do a shortcut. Shortcut here, we want the top to look more like the bottom. So the bottom is plus 5, x plus 5. So in the top, we're going to put a plus 5 and a minus 5. We haven't done anything. Plus 5 minus 5, that's just 0. But now, x plus 5 over x plus 5, that's a 1. And we're left with 5 over x plus 5. Yeah. If you don't believe me, we can do the long division on the side as well. So here we've got x divided by x plus 5. That's going to be a 1. That's going to be x plus 5. Subtract them, we have minus 5. We get the same thing. Okay. So either you do the long division on the side or you do this quick shortcut of plus 5 minus 5. You get the same thing. Okay, so this is going to be x minus 5 natural log x plus 5. Okay, easy stuff. Okay, number 5. Okay, we have the integral 1 over x plus 2. Okay, if I have to ask for there to be silence one more time, I'm leaving. Okay, last warning. One more time, if I have to ask you to keep quiet, I'm leaving. Okay, so we have 1 over x plus 2. Okay, again, partial fractions. We've got some polynomial at the bottom. Also, it's factored. It's factored for us. So we skip step 1, we skip step 2. We can go straight into the decomposition. So this is going to be 1 over x plus 2. We have x by itself, so that's going to be some a over x. X plus 2, there's no repetition or anything, so it's just b over x plus 2. Okay, clear the denominator. So we have 1 equals a x plus 2 and b x. Okay, just clearing that denominator there. Now again, you can do this 2 ways. Multiply out the right-hand side, compare coefficients. So the coefficient of x, that must be 0. There's no x on this side here. The constant must be 1. 2 equations, 2 unknowns, you can solve simultaneously. Or you can let x be 0. That gets rid of the b, solve for a. Let x be minus 2. That gets rid of a, solve for b. You can do it like that. Okay, so if x is 0, then the b term goes away, and we have 2a. So a equals a half. Then we can let x be minus 2. The a term goes away, and we're left with b. So that will be 1 equals minus 2b. So b equals minus a half. Okay, so we've got a, we've got b, all set. The other way, let's just write it out here. So we're looking for the x term, so that will be ax plus bx. So a plus bx. And then the constant term, that was 2a. So like we said, this must be 0 and this must be 1. And we get the same thing. Okay. So that first thing in pink there, that's equation 1. Second one, that's equation 2. You can solve the 2 like that. Again, that's just preference. Both are about the same amount of work. Okay. Okay, so we have a and b. So let's put this together. So this will be the integral of 1/2 1 over x minus 1/2 1 over x plus 2. Okay, both of them, it's just some linear x on the bottom, so natural log. So 1/2 natural log of x minus 1/2 natural log x plus 2. Okay, easy enough. Okay, next one, a little bit more tricky, but not too bad. Number 6, we have the integral x over x plus 1, 2x plus 1. let's just go through the steps again. So step 1, check if we need to do long division. The top is x, the bottom will be x squared. Okay, so no long division needed. Next step is factoring. It's already factored, so that's fine. Okay, so we can skip right to step 3, the decomposition. So x over x plus 1, 2x plus 1 is equal to, they're both linear, so we just have a over the first one, b over the second one. Two x plus 1. Okay, so decomposition done. Next step, step 4, is to solve for the a and the b. So we clear the denominator, so that will be x, a times 2x plus 1, and b x plus 1. Okay, for this one, let's try out the other method. So the previous ones, I let x be 0, x be 1, solve it like that. Let's solve this one as if it were a system of equations. So we're going to have x equals, we're going to have 2a and a b with the x. Okay, and then the constants, there's just the a and the b. Okay, and imagine we have a 0 plus there. Okay, so comparing the x together, we're going to have equation 1. So there's a 1 here, 2a plus b over there. So that's going to be 2a plus b is 1. Okay, and then we've got a 0 here, and a plus b over there. So that's going to be a plus b equals 0. Okay, easy enough. 2 equations, 2 unknowns. We can solve this. Let's subtract equation 1 from equation 2. If you're doing it with like the matrix stuff, you know, row 1 minus row 2 sort of thing. So 2a minus a, that's a, b's cancels, so a is 1. So like your row 1 minus row 2 sort of thing, that gives us a is 1. If a is 1, b is minus 1. Okay, so we have everything we need. Let's write this out. So that's the integral, a is 1, so 1 over x plus 1. B is minus 1, so that comes with the minus 1 over 2x plus 1. Okay, first one, natural log, easy enough. Second one, I noticed a lot of mistakes with this in the quiz. A lot of you were writing just the natural log of 2x plus 1. That's wrong. Okay, x has a coefficient of 2. What happens if we do a u substitution? U equals 2x plus 1, du equals 2 dx, 1/2 du equals dx. This is going to be 1/2 natural log 2x plus 1. This 1/2 here. A lot of you left that out. Okay, when you did the integration of that. Okay. Please check. If you've got 1 over ax plus b, you should have a 1 over a out in front from the u substitution. Okay, many of you left that out. Okay, and then you ended up with that bit being wrong. Okay, no questions yet. Okay, good. Number 7. Okay, we have the integral x plus 2 over x squared plus x. Okay, let's go through the steps again. Even if it's obvious, let's go through it. So the top is linear, x to the 1. The bottom is quadratic, so we don't have to do long division. Okay, again, even if it's obvious, just spend 1 second, look at it and see. Next, can we factor the denominator? Yes, there's an x, we can take that out. So that's step 2. So this is equal to the integral x plus 2 over x plus 1. Okay, if you just follow the steps, you can't get anything wrong. Okay, unless you make like a sign mistake or you can't add or something. But just follow the steps, you have everything you need. Okay, it's factored. two linear factors, we can split them up. So x plus 2 over x plus 1, a over x, b over x plus 1. Okay, two linear factors, a over x, b over x plus 1. Let's clear the denominator. So x plus 2, that will be a x plus 1, b times x. Okay, now you could multiply it out, get a system of equations. It's much easier to just say x equals 0. That gets rid of b. So x equals 0. So 2 equals a. Do it in one line, so much easier. Let x be minus 1. Okay, so 2 minus 1 there, so that will be a 1. And then we have a minus 1. So b is minus 1. Okay, very easy, just substitute. If it's a bit more complicated than this, maybe it will be easier doing a system of equations. But like this, we can see right away. If x is 0, b goes away. If x is minus 1, a goes away. It's much easier if you can see that. Okay, so we've got everything we need. A is 2, so that's the integral 2 over x. B is minus 1, so we have minus 1 over x plus 1. Okay, so 2 natural log of x and minus natural log x plus 1. Okay, very straightforward. Okay. Any questions so far? Okay, everyone's been quiet, so we'll carry on. Number 8. Okay, integral x to the 6 minus 1 over 1 plus x squared. Okay, let's go through the steps. Step 1, check if we need to do long division. The top is degree 6, the bottom is degree 2. Okay, 6 is bigger than 2, so we have to do the long division. Let's do that. So numerator x to the 6 minus 1, and then the denominator x squared plus 1. Okay, x to the 6 over x squared, that will be x to the 4. And then multiplying by x to the 4, we're going to have x to the 6 plus x to the 4. Okay, minus them. So the x to the 6, they cancel. So we're left with minus x to the 4 minus 1. Okay, minus x to the 4 divided by x squared, that's going to be a minus x squared. And then we multiply, so minus x squared times x squared, that's minus x to the 4. Minus x squared times 1, that's just a minus x squared. And we subtract again. So we're left with x squared minus 1. Okay, x squared divided by x squared, that's a 1. 1 times x squared plus 1, that's going to be x squared plus 1. And we subtract them. So x squared minus x squared, that goes minus 1, that's minus 2. Okay, and we can stop there. So we've got that whole number part, the x to the 4 minus x squared plus 1, and the remainder part of minus 2. So we have the integral of x to the 4 minus x squared plus 1 minus 2 over, and then whatever we had in the bottom, that was x squared plus 1. Okay, now x squared plus 1, we can't factor that. Okay, so there's no splitting that up into two parts. But we know already that that's going to be arctan. X squared plus a squared, that's arctan. So this is 1 over 5 natural log, 1 over 5 x to the 5 minus 1 over 3 x to the 3 minus, plus x, missing that one, and then minus 2 arctan of x. Okay, so here the a squared is just 1. So it's going to be 2 over 1 arctan x over 1, but that's just x. Okay, please do not write this as natural log of x squared plus 1. Okay, just because you've got something in the denominator does not mean it's natural log automatically. Okay, 1 over x, that gives you natural log. 1 over x squared plus a squared, that gives you arctan. Yes.
So, one gets.
Sorry?
What's those getting? Well,
Yeah. The log. The only way you end up with the log is if you have something like this. Don't write this down. 2x over x squared plus 1. Okay, don't write this down. This is just to explain. Can you see the red? Is that okay? Okay, so we've got the 2x over x squared plus 1. What happens if I let u be the denominator? What's du? 2x, which is the top. So this becomes du over u, which is the natural log of u, which is the natural log of x squared plus 1. We don't have that here. This is 2 over x squared plus 1. That is 2x over x squared plus 1. Very different. Okay, so please stop making that mistake. I saw that quite a lot in the quiz. So there were questions with 1 over 1 plus x cubed. You wrote down natural log 1 plus x cubed. With 1 over 1 plus x squared, natural log 1 plus x squared. You just put natural log for everything. Don't do that. I'm just going to mark it wrong and move on. Okay, you're not even going to get part marks for that. If you're writing that, it's just straight 0. Okay. Any other questions on this one? No. Okay, number 9. Okay, we have the integral 1 over x squared, 1 plus x squared squared. Okay, so this one's going to be quite a lot. We can see already we've got 2 repetitions. We've got x squared, so that's x repeated twice. We've got 1 plus x squared squared, so we've got that repeated twice. Okay, so let's do the decomposition. So we have 1 over x squared, 1 plus x squared squared. Okay, x squared, that's repeated twice. So we're going to have a over x, b over x squared. Okay, so that bit's done. Then we have 1 plus x squared. We have that repeated twice as well. So that's going to be cx plus d over 1 plus x squared plus ex plus f over 1 plus x squared squared. Okay, so first 2 terms is for the x being repeated. The second 2 terms is for the 1 plus x squared being repeated. Okay, now we can clear the denominator and solve for a, b, c, d, e, f. So we're going to have 1 is equal to ax 1 plus x squared plus b. Okay, the x squared is going to cancel, so that's going to be 1 plus x squared squared plus cx plus d. The 1 plus x squared cancels, so we're left with x squared, 1 plus x squared. And finally, ex plus f, the 1 plus x squared squared, that cancels, so we're left with ex plus f x squared. Okay, so we have everything we need. We can start comparing coefficients. Immediately we can see stuff is going to be 0. Right, over here on this left-hand side, we just have a 1. So the coefficients of x, that's 0, x squared, that's 0, x cubed, that's 0, and then x to the 4, that's also 0. So a lot of these coefficients here are 0. The only non-zero thing is 1. So whatever the constant is, we know that's going to be 1. Okay, I'll leave that for homework. You can try that out. Again, very easy because most of the side is 0. So it's quite easy to do. Okay, but we end up with the integral 1 over x squared minus 1 over x squared plus 1 minus 1 over x squared plus 1 squared. Okay. Okay, like I said, a lot of the stuff will cancel because of all the zeros. Now, these first two, very easy to do. This one easy, that one easy. The one right at the end, we can't do that in one step. Okay? We've got 1 over x squared plus 1 squared. That's not going to work out. So what we're going to do is a trig substitution, right? Because it's x squared. So we can do a trig substitution for this integral here. Okay, homework, you can try the hyperbolic version. Okay, so let's look at this more difficult one. So we have integral 1 over x squared plus 1 squared. Okay, so I'll do the trig substitution. Homework, you do the hyperbolic one. Okay, so we've got x squared plus a squared. So that's going to be a tan substitution. So x is going to be tan theta. So dx, that's going to be sec squared theta d theta. Okay, I did warn you when we were going through the techniques. For some questions, you have to do more than one thing. So in this case, it was by parts, and part of the working is a trig substitution. Okay, so please keep that in mind. You may be starting with one technique. Halfway through, you end up trying to do another technique. You need to know all of them. Okay, so even though you're starting with by parts, you might have to do, even if you're starting with the partial fractions, halfway through, maybe you're doing integration by parts. Or in this case, a trig substitution, or a hyperbolic trig substitution. It's always mixed up. Okay, so in this case, let's carry on with the trig substitution. So this is going to be the integral. The top bit, sec squared theta d theta. Okay, bottom bit, x squared, that'll be tan squared. Plus 1, and then squared. Okay, so we end up with this. Tan squared plus 1, that's going to be sec squared. Squared again, so sec to the 4. Okay, sec squared at the top, sec to the 4 at the bottom. We're left with the sec squared at the bottom. Okay, but sec squared at the bottom is the same as cos squared at the top. Okay, integral of cos squared, you should be able to do immediately now. So we know that's going to be 1/2 integral 1 plus cos 2 theta. Okay, that should be like automatic now. You should know that. Okay, so this will be 1/2 theta plus 1/4 sine 2 theta plus c. Okay, here we've got sine 2 theta, but we want to work with sine theta and cos theta by themselves. We don't want this double angle. So we can split this up. So this will be 1/2 theta plus 1/2 sine theta cos theta. Okay, so instead of the double angle, we've got two standard single angle trig functions. Okay, at this step, we can do the substitution for, yes? You can try, but you will end up with this anyway. Okay, yeah, you can try, but at the end, you'll get the same answer. Okay, so what we want to do is go back to x for the theta, the sine theta, and the cos theta. We're given tan theta. So we know tan theta was x over 1. So we can draw a little triangle. So that's x, that's 1. That's x squared plus 1. Okay, just Pythag to fill in the sides. Okay, so x squared and 1 squared, x squared plus 1. We've got the root. Okay, so that's just Pythag to fill in the missing side there. Now we have the full triangle. We can get any trig ratio we need. for sine and cos. So we're given tan, we can now work out sine and cos from opposite over hypotenuse and adjacent over hypotenuse. Okay, so it's going to be 1/2 arc tan x, just inverting that equation we have in the top right, plus 1/2 sine theta, like I said, opposite over hypotenuse, so x over root x squared plus 1, and cos theta, like I said before, adjacent over hypotenuse, so 1 over root x squared plus 1. Okay, last bit of simplifying, a root times a root, the root cancels, so we have 1/2 arc tan x plus 1/2 x over x squared plus 1. Okay, you don't need to do this last line, right? As long as you've got the substitution correct, that's fine. If you want to simplify further, that's up to you. Okay, I don't mind. Okay, so we end up with that, but that's not the answer. Okay, we've done a lot of work. You might have forgotten what we were doing. Let's go back here. That was just the pink star. We still have to do these ones. Okay, so remember that pink star over there is what we did with this trig substitution. This over here is not the final answer. That's just the third integral. We still need to add everything together. So finally, adding all the stuff together, we get the integral 1 over x squared plus 1 squared. This is going to be all the stuff we had in the beginning plus what we have there. So that's going to be minus 1 over x minus arc tan x minus, now the new stuff, so minus 1/2 arc tan x plus 1/2 x over x squared plus 1. Okay, now this is the full answer. Okay, so this is the pink star stuff we had earlier plus the original stuff we had. Okay, so that reminds me, a lot of you in the quiz as well, you did some side working for an integral, and then you underlined that as your final answer. You left out parts previously. So if we go to just quickly the solutions, not the bonus, this one here. So here, so we had the 3 and then everything else. So a lot of you ignored the 3. You wrote down the solution for the log and you forgot that there was the 3 being added. So this bit you left out. Okay. So yeah, a lot of you just did this bit. This bit here, you got your A and your B, you wrote down the log and you forgot all about this 3 that you had in the front there. You forgot that, I know. Okay. Please don't forget stuff. Okay. So if you're going to do side working on the side, that's not your final answer. Go back to what you were writing and check you haven't missed anything. Okay, because immediately you've lost like 2 marks leaving this out. Okay, so please be careful with that. Let's go back here. Okay, especially for these problems where you've got, a lot of things going on. You might be, using all your time doing this side working. You forget the original problem and you say, there's my final answer. Or you've left out half the problem. You've also left out half the marks. Okay, so careful with that. Okay, that was 9. Number 10. Okay, we got the integral 1 over root x, root 1 minus x. Okay, so someone in the voting asked for the rational substitution, so we'll go through one of those. Okay, so in this case, we've got the roots going on here. We want to get rid of the roots. So this 1 minus x, we want that to be a square. If this is a square, the root gets cancelled. So we're going to have u squared equals 1 minus x. So 2u du is minus dx. So minus 2u du is dx. Okay, so that bit's taken care of. Let's substitute now. So this is going to be the integral. The top bit, the dx, we've got that as minus 2u du. Okay, what about the bottom stuff? Root x, what's that going to be? If we look on the side there, we can solve for x. So x is going to be 1 minus u squared. So we can substitute that. Okay, and root 1 minus x, that's going to be u. Okay, we've got u at the top, u at the bottom. There can go. And we're left with the integral minus 2 over root 1 minus u squared. Okay, now there's two things you can do from here. Either you recognize this as the arcsine integral. So you can just put the answer, arcsine, you get all the marks. That's fine. Or you can do a trig substitution and do it the long way. I'm fine with both ways, whatever works for you. So again, if you recognize this as the arcsine integral, that's fine. Put arcsine, you get all the marks. Okay, you've remembered it, that's fine with me. Or you do a trig substitution, you'll get the same thing. Okay, but let's do it the long way. We've got a squared minus u squared, so that's a sine substitution. So u equals sine theta. So du, that will be cos theta d theta. So this is going to be minus 2 integral cos theta d theta over root 1 minus sine squared. Okay, so that's minus 2 integral cos theta d theta. 1 minus sine squared, that's cos squared. Root of cos squared, that's cos. Okay, they cancel. So we're left with minus 2 integral d theta. That's just minus 2 theta plus c. We know sine theta is u, so theta is sine inverse of u. So this is minus 2 sine inverse of u. So again, if you recognize that it's going to be sine inverse, go ahead, write it down, get all the marks. Or you do the side working with the trig substitution. Okay, there's no extra marks for doing the side working. If you need to do it on the side, that's perfectly fine. If you know the answer right away, that's fine as well. That's up to you. Okay, but we're not done yet. This is in terms of u. We want it in terms of x. So that's going to be root of 1 minus x, just solving for u. So this will be minus 2 sine inverse roots 1 minus x. Plus, if you remember that it's arcsine, it saves you some time with that side working. But just a note for time allocation, all of the time allocations are assuming you do it the long way. Okay, so for all of the questions, I take the maximum possible time, and that's the time you have. So for this one here, I assume that you're going to do it the long way with all of this. So you have the time to do it the long way. If you know the answer is arcsine already, you've saved extra time for that. Okay, but all of the time allocations are assuming you do it the longest way possible. Okay, any questions on this one? All quiet. Okay. Next one, the next highest voted thing was the hyperbolic trig substitution. I think that got 5 votes, so we'll do that next. So number 2, hyperbolic trig substitution. And like I said earlier, for these problems, I'll point out where you can do it 2 different ways, or sometimes 3 different ways. So we'll start off with number 1, integral of x x squared plus 2 squared. Okay, this one here, you can do it using a trig substitution, the tan substitution, so that's number 1. You can do it with a hyperbolic trig substitution with hyperbolic sign, and you can do it with a u substitution. So that's 3 different ways you can do this. For the u substitution, you just say u equals x squared plus 2. Okay, you can do that for homework. I recommend doing it the u substitution way. Much easier. Okay, much easier to do it that way. However, for learning purposes, we're going to do it the long way with hyperbolic. But again, in the test and the exam, please make sure the first thing you check is u substitution. Okay, don't be clever and try to do it hyperbolic way first. You're going to mess yourself up. Do it the easy way first. If you then have time, do it the other way. Okay, please do not try to be clever and do it the longer way first. Okay, you're just ruining it for yourself. Okay, but again, for learning purposes, let's do it the long way. So, hyperbolic trig substitution, it will be sine hyperbolic, because over here is the x squared plus a squared. So, this is going to be integral x squared plus a squared. Okay, so x squared plus a squared, that is sine hyperbolic. So x equals sine hyperbolic u, and we put the a is root 2. So root 2. Yeah. So sine hyperbolic, and then in this case, a is root 2. So dx, what's that going to be? That will be root 2 cos hyperbolic u du. Okay, we've got everything we need. Let's substitute. So x, that's going to be root 2 sine hyperbolic u. Then we got the brackets, so that's going to be brackets 2 sine hyperbolic squared u plus 2. Then squared again. And then dx, that's going to be root 2 cos hyperbolic u. Okay, so again, we've got the x squared plus 2 squared again, and then the dx. Okay, so we're going to have a 2 from the 2 root 2's there. We've got the 2 inside there. Okay, so let's simplify that. So we've got a 2 from this times this. That gives us a 2. We can take that out. Then we're going to have sine hyperbolic u, cos hyperbolic u. Then here we've got another 2 that we're going to be taking out. Sine hyperbolic squared u plus 1 squared. Okay, but that will end up being a 4, so we can take that out. So that will be a 8. Okay, inside we're going to have sine hyperbolic squared plus 1. That's going to give us a cos hyperbolic squared. Okay, so we end up with that. Okay, 8, oops. 8 integral. So that's cos hyperbolic squared u squared again. So that's 4. We've got another one. So that's 5. And then sine hyperbolic u du. Okay, good. So that's just putting all the coses together and then the sine on the outside. Now think of this as a normal trig integral. We've got a cos and a sine. The derivative of the cos will be the sine. Yes. Yeah, so here this is 2 squared, so that's 4. And then we had a 2 out in front here, and then that's 8. Okay, so we can't do a u substitution. We've already got u, so let's call it t. So we have t equals cos hyperbolic u. dt will be sine hyperbolic u du, which we have on the side there. So that's going to be 8 integral. Cos was t, so that's t to the 5 dt. That's the sine hyperbolic there. Okay, so this will be 8 over 6 t to the 6 plus c. So this will be 8 over 6. T was cos hyperbolic u, so we can put that in. To the 6 plus c. Okay, so that's now taken care of. Now, what we want to do is change from cos hyperbolic u back to x. So here, remember, sine hyperbolic u, we could write in terms of x. Here we have cos hyperbolic u. So we need to do a bit of rearranging there. So let's write this as 8 over 6 cos hyperbolic squared cubed. Okay, so I haven't changed anything, but I just took the 2 inside, so it becomes cos hyperbolic squared. Why? Well, because we know cos hyperbolic squared and sine hyperbolic squared, we can go between them. So if we've got cos hyperbolic squared, we can write that in terms of sine hyperbolic squared, and we know what that is. Okay, so let's put it all together. So x squared over 2, this will be sine hyperbolic squared. Now we want to change from sine hyperbolic squared to cos hyperbolic squared. So we're going to add 1 on both sides. So x squared over 2 plus 1 is going to be sine hyperbolic squared u plus 1. Okay. Now sine hyperbolic squared u plus 1, that's cos hyperbolic squared. So that's going to be x squared over 2 plus 1 cos hyperbolic squared u. Okay. Which is what we wanted. We wanted cos hyperbolic squared. So we can just substitute now. And we can simplify 8 over 6. That will be 4 over 3. This will be x squared over 2 plus 1 cubed. Okay. We don't need to simplify any further than this. We can leave it like that. Okay, now you see this is much longer than if we did a u substitution. If we did a u substitution, easy stuff. That bit's u, we've got du, we just add 1 to the exponents and divide. Much, much easier. But, if you want the bonus marks, you can do this afterwards. I'll give you the marks for that. But please, again, make sure you check for u substitution first. Okay, that should always be the first thing you check. Okay, number 2. Okay, here we have the integral 1 over x squared plus 4x plus 5. Okay, the first thing you should be thinking of is partial fractions. That's always the first thing. But again, for learning purposes, we're going to do this using hyperbolic trig substitution. Okay, so the first thing we need is some x squared plus a squared in the bottom there. So we need to complete the square. This is going to be the integral 1 over x plus 2 squared minus 4 plus 5. Okay, so this will be integral 1 over x plus 2 squared plus 1. Okay, so we did completing the square. We've got our x squared plus a squared. So x squared plus a squared, that is a sine hyperbolic substitution. The same as the first one. So we're going to have x plus 2 is equal to sine hyperbolic u. We need dx, so differentiating both sides. Dx will be cos hyperbolic u du. Okay, good. Now we can substitute. So this is going to be the integral. We're going to have the cos hyperbolic u du at the top. And in the bottom, what are we going to get? X plus 2 squared. That's going to be sine hyperbolic squared. And plus 1. Okay, easy enough. Now, sine hyperbolic squared plus 1, that's cos hyperbolic squared. We've got cos hyperbolic squared at the top, cos at the top. One of them will cancel. So we end up with the integral 1 over cos hyperbolic u du. Okay, so this is now the integral of sec hyperbolic u du. Okay, at this stage, there's two different things you can do. Either you know the answer for this because you did the homework problem, or you can do it the long way. So let's just show that on the side here. So sec hyperbolic u, that's going to be 2 over e to the x plus e to the minus x. Yeah, right, because it's 1 over cos hyperbolic. So if we wanted to integrate this, that will be the integral 2 over e to the x plus e to the minus x dx. Okay, that was one of the homework problems. We'll just go through it quickly here. So that will be 2 e to the x over e to the x squared plus 1. And then here you would have to do a t equals e to the x substitution. Okay, you can do that again if you didn't do the homework, but you end up with this being tan inverse sine hyperbolic u. Okay, there's different versions of this depending on the identity you're using, but this one is the easiest one to use because sine hyperbolic is just x plus 2. Okay, so we're going to use this version. There's another one where it's 2 arctan e to the x. You can write it like that as well. However, in that case, it's going to be a bit difficult to solve for x. So we're not going to use that. Okay, but this is easy. This is just tan inverse x plus 2. Now, we took the very long way around doing this. If we go back a few steps to this, well, at this point, we can see the answer immediately. Because this is just like u squared plus 1. That's arctan, right? Yes? No? Okay. If I have 1 over u squared plus 1 du, that's arctan u. In this case, it's x plus 2, so it's arctan x plus 2. Okay, so we did the very long way around. You could have done it in one step. Okay, but again, for learning, we're going to do it the long way. Any questions so far? All good. Okay. Again, please, this is not the first thing you look for. The first thing you look for is u substitutions, partial fractions, that type of stuff. Please do not do it the long way like this. Okay, unless you want the bonus marks, then go ahead. Okay, next one, number 3. So we have the integral 1 over x squared root 9 minus x squared. Okay, this one you can do two ways. You can do it with the trig substitution, because we've got 3 squared minus x squared, trig substitution, or you can do it with the hyperbolic trig substitution. So let's do it the hyperbolic way. Here we have a squared minus x squared, so that's a tan hyperbolic substitution. So x is tan hyperbolic u, but the a is 3, so we need to put a 3 in front there. Okay. If we were to do a trig substitution, which one will it be? Yep. Which one? Sine. Everyone agree? Someone say no. Okay. Okay, just checking. Yeah. Okay, so we have dx equals the derivative of tan hyperbolic. Again, you just treat it like tan, so this will be sec hyperbolic squared. Okay, sometimes there's a minus that you need to worry about, but most of the time you can just treat it like the trig functions. Okay, so let's substitute. So in the top, we're going to have the sec hyperbolic squared. du. In the bottom, we've got x squared, so that's going to be non-tan hyperbolic squared. Okay, and then the roots, non minus non-tan hyperbolic squared u. Okay, so that's all the substitution done. Okay, again, please be careful you don't miss things out when you substitute. So here we've got x squared in the front there. Please don't, magically leave that out in your next line. Okay, double check you've done the substitution correctly. Okay, integral. Let's see what we can simplify here. So in the root there, we've got a 9. Root 9 is 3, so that cancels with the 3 at the top. We've got another 9 here, so we can take that out. So let's write that as 1 over 9. Okay, sec hyperbolic squared u du, that can stay. Tan hyperbolic squared u there. Okay, 1 minus tan hyperbolic squared, that's sec hyperbolic squared. Then we take the roots of that, so that's just sec. So that's 1 over 9 integral. Sec squared at the top, sec at the bottom. We can cancel one of those. So we have a sec at the top. And we still have the tan squared at the bottom. Okay, so 1 over 9 integral. Now, written like this, it's a bit of a mess with the sec at the top, tan at the bottom. So let's change it to the sine hyperbolic and cos hyperbolic. Makes it a bit easier to work with. So sec hyperbolic at the top, that's 1 over cos hyperbolic times. And then tan hyperbolic, that's the sine over cos, but it's 1 over tan, so it will be cos over sine. Okay, cos squared at the top, cos at the bottom. One of those will cancel. So that's going to be 1 over 9. We still have the cos at the top and sine squared at the bottom. Okay, easy enough. We do a little t substitution. If t is sine hyperbolic squared, if t is sine hyperbolic, dt is cos hyperbolic. So it will just be minus 1 over sine. Okay, plus c. Okay, now we want to change back to x. What are we given? We're given tan hyperbolic. That was our substitution there. So tan hyperbolic u is x over 3. So we're given tan. That was x over 3. What we want is sine. So we need to get from tan to sine. There's a bit of a in-between step we can use. So tan hyperbolic squared, we can write that in terms of sec hyperbolic squared. Okay? Sec hyperbolic squared is 1 over cos squared. Once we have cos, we can then have sine. A bit of an in-between step. So let's start with this. So 1 minus tan hyperbolic squared u is going to be 1 minus x squared over 9. If you don't know the identities, you're going to be completely lost with this. Okay, so please go over your identities. So this is going to be sec hyperbolic squared u is 1 minus x squared over 9. Okay, good. Now we want this to be in terms of cos. So 1 over sec hyperbolic squared, that's cos hyperbolic squared. so that's easy enough there. You got a question?
You just did this.
Sorry?
You,
Yeah, we just flip it. Yeah. Yeah, so cos hyperbolic u is 1 over sec hyperbolic u. Okay, so cos hyperbolic squared u. I don't want a fraction in a fraction, so I'm going to write this as 9 over 9 minus x squared. Okay, just to simplify things. Okay, now that we have cos hyperbolic squared, we can write this in terms of sine hyperbolic squared. So cos hyperbolic squared u minus 1. That's going to be 9 over 9 minus x squared minus 1. Why? Well, cos hyperbolic squared minus 1, that's sine hyperbolic squared. Okay, and then minusing 1, that simplifies to x squared over 9 minus x squared. Okay, finally, taking the roots on both sides, we get sine hyperbolic u is x over roots 9 minus x squared. Okay, which we can then substitute into what we've got there. So this is going to be minus 1 over 9. And then we'll just flip it because it's 1 over sine. Okay. Okay, so again, the first thing you should try is the trig substitution. A lot easier to work with. You know your trig identities. If you then want to try the hyperbolic trig substitution, you can do that afterwards. Again, don't be clever. Don't start with this. You're going to mess up. Okay, do the safe way first. Then, if you've got some time, try it this other way for the bonus marks. Okay, so you'll get like what's it? If it's out of 7, you'll get 14 out of 7 if you do it both ways. Okay, so that's number 3. Okay, number 4, last thing for today. So we have the integral of roots x over 1 plus x dx. Okay, again, I'm going to repeat myself. This has the root x. You do the rational substitution and you do it using partial fractions. Okay. But if you want the extra marks, you can do it the other way. Okay, but please do it the easy way first. You don't want to mess up with the timing. Right? You try it the hard way, you mess up, now you've wasted 10 minutes. Okay, first thing, we want to get rid of the roots. So let u be u squared be x. So root x, that cancels with the square. So 2u du is dx. So this now becomes the integral of root x, that's going to be u. Dx, that's 2u du. Over 1 plus x, that's 1 plus u squared. Okay, so the 2 can come out. Integral u squared over 1 plus u squared. Okay, from this point, please do not do a trig substitution or hyperbolic trig substitution. Waste of time. Over here, you do a plus 1, minus 1, you separate it out and you integrate. Okay, you don't do it the long way. But again, for learning purposes, we're going to do it the long way. So 1 plus u squared, that's a sine hyperbolic substitution. So u equals sine hyperbolic. We already have u, let's call it t. So du, that will be cos hyperbolic t dt. Okay. Now we just substitute. So we've got the 2 on the outside. Integral u squared, that will be sine hyperbolic squared. Then du, that will be a cos hyperbolic t dt. And in the bottom, 1 plus sine hyperbolic squared. Okay, so we got all of that. A lot of simplifying now. So 2, that can stay out there. 1 plus sine hyperbolic squared, that's cos hyperbolic squared. Yeah, the top can stay the same, but in the bottom, cos hyperbolic squared. Okay, cos at the top, cos squared at the bottom. One of them will cancel. So we end up with 2 integral sine hyperbolic squared over cos. At this point, we're a bit stuck. Can't really do a u substitution. Maybe there's a identity you can use with sec and tan hyperbolic. We can try that out. But what I'm going to do is split the sine hyperbolic squared into cos hyperbolic squared minus 1. Because we've got the cos at the bottom. So it makes sense. Okay, but you can try something else. So that's going to be 2 integral cos hyperbolic squared minus 1 over cos hyperbolic t. Okay, again, the reason I'm doing that is because this will just be a cos. That will be a sec. We know the answers for that already. So this is going to be 2 integral cos hyperbolic t minus sec hyperbolic t. Okay, and we know the answers for this. Okay, but you can try something else. Maybe something with tan hyperbolic. See what you can do with that. So this is going to be 2 sine hyperbolic t minus 2 arc tan sine hyperbolic t. Okay, so that bit's done. Now let's see what we've started with over there. Sine hyperbolic t is u. So let's put that in. So this is 2u minus 2 tan inverse of u. Okay, now we're not done yet. We need to go back to x. So u squared is x. So 2u, go back up here. The roots on both sides, that's root x. And root x. Okay, so very long amounts of working, but if we go back to here, what I told you to do, this bit there, the u squared plus 1 minus 1 over u squared plus 1, this will be integral 1 minus 1 over u squared plus 1. This will be u minus tan inverse of u. So I did that in 3 lines. And if we go down to here, we've got that there. Okay. So it's a long way around, but we end up with the same thing. Okay. So you'll get a whole lot of bonus marks for doing it the long way. But again, don't waste your time. If you don't think you can do it, rather not go for the bonus marks, rather go for the actual marks for the test. Okay. You're only given a certain amount of time for the test. If you waste your time with the bonus marks, you can't come to me and say, sir, I didn't have enough time. Okay. You're given time for the test. Bonus marks is bonus. It is up to you whether you do them or not. Okay. So please, no complaining afterwards saying, sir, I did the bonus marks, I didn't finish the test. That's not on. Okay. Any questions on this? Yeah. Yes. For the integral of sec. Yeah, the integral of sec. So here this was integral sec hyperbolic t dt. If you want to do it the long way, this will be 2 over e to the x plus e to the minus x. Sorry, not xt. E to the t plus e to the minus t dt. We can write that as 2 over e to the t squared plus 1 e to the t dt. And then you just do a u substitution with e to the t. You'll end up with arctan sine hyperbolic t. Okay. A bit of identity stuff, but you'll end up with that. Okay, but it's best to just learn what it is. Okay. Any questions on the hyperbolic trig substitution? Okay, and hopefully I've convinced you there's a whole lot of ways you can answer these questions. Okay, so for the class test, I have question 1, use substitution. So I'll tell you what you should use. It is entirely up to you whether you use my guidelines or not. Okay, so question 1 clearly says use substitution. If you have no idea what to do, you do use substitution. If you then want to try other stuff, you can do that as well. Question 2 says integration by parts, which means you can do it using integration by parts. If you want to do something else, that is entirely up to you. You can use whatever method you like for whatever question you like. Yeah, but I do have the set guidelines for the class test. For the June test and the final exam, there are no such guidelines. It will be question 1, 40 marks, integrate. You use whatever you want. If you want to use trig substitution, you want to use bar parts, entirely up to you. I give you no hints for the June test and the final exam. You can do it 2 ways, you can do it 3 ways, you can do it 1 way. Entirely up to you. Class test, I tell you what's the best thing to do, but again, you can ignore it. Question 1 is on use substitution. If you want to do it using integration by parts, go ahead. That's fine. You do whatever you want. Okay. Any questions on that? Yes.
Integrated by class guideline that you told us.
You do whatever you want.
The same marks.
You do whatever you want. All of the marking is the same. Yep.
But assuming we get certain way to pick per se, range of guidance and the way to get evaluate, will the class what it being things?
Yeah, the weighting is the same. So if the question's out of 5, if you do it 1 way, you get it right, you get 5. You do it another way, you get it right, you get 5. Okay. But I'll mark it the first way, and then I'll mark the second way, then the third way, in whatever order you present it. So again, if whatever's written first, I assume that's your test answer. If you get that wrong, you get 0 for that bit. Then I look at your bonus stuff. If that's right, it's right. If it's wrong, it's wrong. Okay. Whatever is first, that I'm assuming is your test answer given to me. Anything after that, I assume is bonus. Okay. Same thing with the June test. Any other questions? Yes? Paper for class test? No, you'll get paper for that. Yeah, it's only for the quiz because it's like 1 page, just to fill in. Yeah, class test, you'll get paper. June test, I think you write on the question paper. Final exam on the question paper. Anything else? Well, good. Okay, so that will be it for today. Tomorrow we'll finish off with the integration by parts revision. And I think the next one was trig integrals. Okay, we'll do that tomorrow.